Okay, let's check our answers to the yellow packet, 11.4, just 1 through 4. There's just a couple comments I want to make on here. Some I thought would be a little clearer if I could just talk through them with you. Number 1, nothing too crazy going on here. Notice what I have circled. We're always looking for a pair of sides, a pair of corresponding sides whose lengths we already have. So this is the ratio I worked with as I went through. I did 1.2 to 3.2 equals, and then just set up the appropriate ratios to find H and J. So 0.9 for H, 4 for J. Okay. Number 2, this one takes a little more thought, and let me tell you right off the bat the mistake that I was so tempted to make. This whole big triangle, we do not know that that's a right triangle. So X and Y are fairly straightforward to find, but you cannot just use those to then find this third side, okay? So what we can do is use this ratio 8 to 3 to find our missing sides I labeled X and Y. So we could do, let me just write out one of them here, 8 over 3 equals 10 over X, or 8 over 3 equals 12 over Y. So you end up getting 3.75 for this side, 4.5 for that side. Again, it's tempting to use the Pythagorean theorem here, but we don't know that this is a right triangle. So let's avoid doing that. But we do have right triangles in here. They're just these little guys. So you can use 3, this missing side, and 3.75 as a right triangle with the Pythagorean theorem to find that missing side. Just make sure you put 3.75 as the hypotenuse. So in a squared plus b squared equals c squared, 3.75 is going to go in for c. Okay, so this little piece, after you do that, this is 2.25, and this is about 3.35. There's some rounding involved in that one. So then these together are approximately 5.6 or so. Okay, so that's the 3 sides for that one. In number 3, 2 things going on here. So we're just setting up ratios between the 2 triangles, but then we also have that new angle bisector conjecture. So we'll get to that piece in a second. So 28 and 16, this is sort of the ratio I stuck with the whole time. If you find it more helpful to reduce that, if it's just a little easier for you to work with, you could potentially even do some mental math then. Feel free to reduce that. That's 7/4. Okay, so for example, if I'm now looking at this piece and this piece, my ratio is 7 to 4. Well, this is just 7 times 2, so this has to be 4 times 2, or 8. Okay, so feel free to kind of use the ratios that way if you'd like. Let me fill in the rest here. So WX is, let's see, about 13.7. It's exactly 96 sevenths, or 13 5/7. Let me write it that way first. But if you have about 13.7 for your answer, that's fine. Some rounding in there, but just know that if you use this rounded number to find any of these other missing pieces, it's going to throw those answers off a bit. Okay. Okay, let me see. Where did I go from there? Oh, we can find the length of this angle bisector. So that's fairly straightforward because we have this 12 that's here, right? So 28 to 16 equals x over 12. This is exactly 21. And then this little guy, let me just call this y for right now. This is where the angle bisector conjecture comes in. So remember, we can do something with a long side, long piece, short side, short piece sort of setup. So I have, let me see if I can see which one I actually ended up using here. I can't tell. So we'll just start from scratch. So 28, let's say we did it this way. 28 over 14. 28 over 14 equals, so that's long side over long piece, equals short side over short piece. So that would be 24 over y. Okay, that ends up being, oh, y is 12. Okay, if you can see, this is just 2 to 1, 2 to 1 right here. Okay, so this piece is 12, so that's dB. xz, actually, once you have that, you can just go kind of between the triangles and use this 7 to 4 or 28 to 16 ratio to find all of those. So let me just fill in what we've got here. xz is, am I reading that right, 48 sevenths? About 6.85. If you had that, I'll put the approximation here, but 48/7 is the exact answer. AD we found together, that's 21. And then, oh, YZ I found also is exactly 8. Oh, I guess you didn't need. Oh, what did I do here? Oh yeah, ZX, that's the one that we had to round. It's about 6.85. Okay, and then number 4, we did one like this together in the notes yesterday, but let me help you with that one. So this is, we're going to use the angle bisector conjecture, where it divides this side proportionally in the same relationship as the sides that form that angle. So this time, let's say maybe I wanted to do 5/8. Now that equals x over y, but if I write x over y, I don't know which one to solve for, right? I can't solve for either one of those. I have too many unknowns. So instead of leaving it, oh boy, oops, wrong button there. Come back to me. There we go. So for if I want 5/8, I'm going to do x over, not y, but let's think about how we could rename y. That is, oops, I'll write it this way, 10 minus x, right? Together, these two lengths are 10. If I already used up x of it, I'm left with 10 minus x. So that piece, that long piece, I'm going to call 10 minus x. So just be careful now when you're cross multiplying, because you do need to distribute. So we get 8x equals 50 minus 5x, right? 5 times this quantity. Add 5x to both sides and divide by 13. You can leave it as 50/13, or the approximation of that's fine. And then to get, just plug this back in, right? 10 minus that gives me 80/13 for y. If you had, let me see, what is that? 50/13 is about 3.8 and 6.15. Okay, so let me put those there as well. About 3.8, this is about 6.15. So if you had those, you're on the right track. Just some rounding differences there. Okay, thanks for checking in.